Mr. Sand, and this is a walkthrough for adding vectors. So first I'm going to start off with a simulation that I linked to online, and it's a simulation that's really great. It's through a company at PhET in Colorado. What you do is you just go to this link and you grab one of these vectors. Let's see if I can grab one. Okay, grab this vector, and you can move it around in whatever way you want to, and you can see over here, this shows the magnitude, that's the uppercase R. This shows the angle from horizontal over here. So if you go down to this, it goes up negative, and it goes negative all the way over here until we get to 180, and then it goes back to 180, positive 180, and it goes back up to 90, and so forth. Okay, so it's in terms of degrees. And it has an X component and a Y component. Right here, it's nice. At 36.3 degrees, I can put this down over here if I want to, right at the origin, so it's a little bit easier to see. But you can really put these vectors anywhere, but origin's a little bit easier to see. At 36.3 degrees from here, we have an X component, 15 units, whatever units you use here. I'll show the grid. 15 of these little blocks. Perfect. And it'll be exactly 11 blocks up. Now, if we use meters here on this axis and this is a position then, a position vector, it shows you maybe this is like east, the direction east, and that's north, and then we can often say that this would be south, and that'd be west. So this would be 15 meters to the east and 11 meters to the north for this position vector right here. A couple cool things you can see on this little simulation is if you go like this, you can click on the different kinds of styles. It shows components. So over here it shows you that this vector is really just made up of this y vector and this x vector right here. If they added together, they would get this red vector right there. So I'll use this style. This style is really great. This is my favorite. It shows you there's the tail, there's the tip of this vector, and then this is the tail, and that's the tip of this vector. If you add them together, then you get this resultant vector, this red vector right here. And I can also show you this. This is also cool. It shows like the shadows cast. It shows like right here, this line. That's pretty cool. And if I take off the grid, you can see a little bit easier. In fact, I'll keep the grid off for now. What I'm going to do is I'm going to just show you this vector. I'm going to take off the components, and I'm going to show you another vector added to it. So I'm going to give this vector plus another vector. I'll put another vector like this, a slightly different angle, and I'll put it up like this. And now I'm going to show the sum. So I'm going to add this vector plus this vector right over here. And what you can see is that this is big green vector just floating in space. But what this big green vector really is that right there. It's the tail of the first vector, all the way from the tail of the first vector to the tip of the second vector. So if you add these vectors together, tail to tip, you can see that this is the resultant, this green vector is the resultant. Now if I show the components in my favorite style, like this, this is so great. You can see the x component of this first vector plus the x component of the second vector. They add together to get this component vector, the resultant vector, this green one all the way over here. And the same thing goes for the y. On the y-axis, the y component of this vector plus the y component of this vector will get you this y component of the resultant. So this x component of the resultant vector plus the y component of this resultant vector gets you the resultant if you add them together, which is this green line right here. This is fantastic. I'm so happy that this exists, this simulation, because it shows so clearly what's going on when you add vectors together. That's about all we got. Now, if you want to subtract a vector, all you'd have to do is take a vector, let's say that this vector subtracted by this other vector right here. Let's say this one subtracted by this one. Well, then you just have to flip its orientation, and it's hard to do in this little simulation, but I'll try. So it's like this, it's flipped. So there you can see that now this x component is actually going backwards, and the y component is now going backwards as well. So it's been completely flipped. And so the resultant is going to be the same thing as tail to tip, or tip to tail, sorry. It's this tip to the tail of the next one. and the resultant is going to be the resultant of from the first tail to the second tip. So this is a green line right here. If I take off this, you can see a little bit clearer. And again, if you can add if you want to see this, you can see the components added together will actually get you this little green value right here. Okay, so that's the simulation. Play around with that, have fun, make very complicated vectors and take screenshots of those, sending me the screenshots via email or just Dropbox. I think we're going to enable a Dropbox for this class, but email's a safe way to go. And that's at mrbishopsand@gmail.com. Now, let's go through a couple warm-up problems. Here we go. So if you look at the workbook, for the following problems, write S if the measurement's a scalar, V if it's a vector. So for time, that's going to be a scalar. So let me get my pen right here. Let's use strawberry. Okay, so this is a scalar. Why is it a scalar? Because it doesn't have a direction. There is no such thing as a negative time. It only goes positively. Vector for velocity has a position. It has a magnitude and a direction. Volume, that's a scalar. There's no direction for that. Distance, we're going to see, just is a scalar. And position is a vector. Why is that distance not a vector? The reason? Because it doesn't have a direction. It's just a certain distance. So if you go, let's just have a little drawing right here. Let's say this is the origin, and you go in this red path, like this, just wandering away from that origin. Your distance is all of this red that I've drawn in right here. That's a very long distance. But your displacement is it's a straight line from where you finish to where you begin. It's your change in position from the very final point to the initial point. So this is your position, change in position. It has a direction right here. It has a direction. We can mark that direction with respect to another line if you want to. Maybe it'll be like that angle right there. But distance doesn't have any angle representing it. It's just a total distance that you travel. Position is with respect to the origin point. Okay. So I kind of went into position and displacement there, but we'll go through that a little bit more in detail later. Anyway, let's go on to number 2. Approximately to the best of your ability, at the position of Tommy and Deborah in the graph below by drawing the resultant vector. Well, first, I'm going to add Tommy to Deborah. There's 2 ways I can do this. I can either add Deborah to Tommy or Tommy to Deborah. It says add the positions of Tommy to Deborah. So I'm going to take Tommy right here. I'm just going to get a feel for this. It's about that and that angle. So I'm just going to transfer this right about here. I'm going to say that is Tommy's vector. It's approximate, so don't kill yourself with getting exactly the angle here, even though that will be important later. I just want to get the concept of adding this vector. You're going to need to add the magnitude, so that's the length of this, and its angle. So that's the direction of it. So it's about like that. So if you add the 2 together, you're going to get this Deborah plus that, and that's Tommy, of course. So all right, Tommy there. And if you add their positions together, you're going to get a resultant. And the resultant's going to be from here, from the origin where Deborah is, all the way to Tommy. If that was a straight line, it'd be something like this. Right there. So that's the resultant. Also, I'll write in resultant. And that's the answer. The green is the answer. Okay. I hope you enjoyed this. Good luck with the warm-up problems. Bye.